And okay. Good afternoon, everyone. Welcome to the Patel College of Global Sustainability Speaker Series. This afternoon, we have a very distinguished scientist and a friend of the college with us to give a stimulating presentation. I will spend a minute or so to read Bob Bunting's biography. Bob Bunting is a scientist and serial entrepreneur, high technology startup expert, and educator who earned his graduate degree in atmospheric sciences from St. Louis University. He's also the CEO of the Climate Adaptation Center, CAC, a Sarasota-based independent 501c3. That means that you are a nonprofit organization whose mission is to bridge the gap between the latest scientific research and the public's understanding of our changing climate and how it impacts where we live. It is a prototype for future CACs in different markets. Bob has worked in government, industry, and academia. He was the director of the University Corporation for Atmospheric Research, or UCAR, where he was a scientist and executive vice president. I think this is at the University of Colorado, Bob, if I'm correct?
That's the National Center for Atmospheric.
Yeah, in Boulder, Colorado, right.
In Boulder, yes, and then also at the University of Colorado.
Oh, excellent. He was also a co-founder of UCAR Foundation, where he commercialized technology used for atmospheric and climate research and founded the Corporate Affiliates Program. In addition, he was a lead forecaster for the National Weather Service and scientist at the National Center for Atmospheric Research, NCAR. He was COO and co-founder of the University Corporation for Atmospheric Research Foundation, which oversees the commercialization of all intellectual property generated by NCAR. With that, I will stop. Bob, the stage is yours. So you can spend up to 30 or 40 minutes or so, then we'll have Q&A. I hope a stimulating afternoon with you.
Govind, and thank you so much. And thank you also to Clara, who introduced you and I, and we became fast friends.
Indeed.
Partly because our interests are so similar. And of course, I spent about 1/3 of my career in the university environment and loved every minute of being at the university. And I certainly admire and respect what you're doing there at the Global Sustainability College. It's so important, and I think more and more important every day. So I'm very happy to be here with you all today, and to all the guests who are online today, and hopefully someday soon we'll all be together for conferences where we can shake hands again and feel good about it. So anyway, my talk today is really about climate warming in the sense of how it's going to impact us right here in Southwest Florida. And science has really moved forward in the last 30, 40, 50 years to where I am now very confident that we can make very skillful forecasts for the conditions we'll see in 2030, 2040, and 2050 here in Southwest Florida, and what choices we can make to make the coming changes better from an adaptation point of view, a mitigation point of view. And of course, during that time, I'm quite confident the world will come together, as it does often in these grand challenges, and we'll be able to solve the climate issue in a bigger way globally. But before we get there, we're going to have to adapt and mitigate the worst impacts of climate warming. So before I get into that, let me just talk about the CAC. Govind said it was a 501c3, which means that we're a non-for-profit organization. We're federally tax exempt. And that means that we can do our work without the influence of any individuals, organizations, etc., who may have a message they would like to deliver. We want to keep our message clean. So therefore, we are 100% donor supported. So that's a big thing to do in this day and age. But we want to make sure that what we say is above criticism from the point of view of any interest that may not like what we have to say. We're going to say what we want to say loud and clear based on the science. We have a world-class group of scientists. My CTO is Dr. Stu Waterman. He's a PhD in atmospheric science, an expert. Actually, he received his PhD from the Snow and Ice Data Center affiliation with the University of Colorado, even though he's a Canadian citizen, and now he's a US citizen too. And any of you who came to our climate conference at the University of South Florida, Sarasota, Manatee, on November 19th, would have met Stu. We also have a Nobel Prize winning scientist, Dr. Robert Carrell, who is really a national treasure. He is so involved with climate warming around the world and was part of the 2013 group of scientists that won the Nobel Peace Prize. So together, we have learned a lot over the years, myself included, and that is that if we're going to solve the climate problem, it can't just be from the top down, it has to be the bottom up. And that's why we have the CAC. Our mission is to build it into a focal point that connects the science community with the public sector, and that means academe, it means private enterprise, and it means governments of all levels, especially in Florida. And so we can help inform decision-making so that the cost-effective adaptation strategies that are available will actually be implemented. And people always say, well, there's not enough money to do that. Believe me, we're spending a lot of money right now, and not all of it is well spent. So it's not just a question of more money, it's a question of organizing regionally so we spend the money better. The following forecasts were made by myself. We will update these every year at the annual CAC Climate Weather Forecast Conference. The next one, it will probably be this November. We haven't selected a date yet, but if you go to our website, the climateadaptationcenter.org, you can find out about what we're doing. We have about 10,000 people coming to the website each month now from all over the world. It's only been up for 1 year, so it's really been a smash success. Also, if you would like to join the CAC, we do have memberships, and you can also register for our newsletter on site. It just so happens today we're upgrading the website, so not all of the functionality is there. But in the next few days, it'll all be upgraded. We're doing a major upgrade as I speak. Our science toolkit that gives us the tools we need to make these forecasts include incredible supercomputing, sophisticated computer models that have visualization, so we don't actually have to look at data anymore. We can actually see the visualization of the data in a movie in real time. This means big data, and this is global data, and we have data sets all over the world. Probably the biggest data set ever compiled is on the atmosphere, and it's terabytes and petabytes of data. It's a lot of data that we have to sift through every day. The advances in science in my career has been incredible. I would say that we've gone from alchemy to chemistry, if you know what I mean, during my career. And the latest new thing is attribution science, where we can run models now on specific weather events, and we can attribute whether climate warming had an influence on those systems, like Hurricane Ida, for example, that struck New Orleans as a Category 4 and went up into New York City and literally drowned people in Manhattan. when they had record rainfall from what was then not even a tropical storm. So we're ready to forecast. The risk of waiting is much higher than not having a perfect forecast. So our forecast inputs really are past climates. We can run the climate models now backwards from today and reproduce the ancient climates. We have over 1 million years of climate data, some of it from ice cores and sediments, and some from instrumentation. And now every day we have incredible amounts of data from new satellites. There's a new satellite that was just being launched today, the new, which will be NOAA 18, which will be in service by hurricane season, which is coming up. So that's a good thing. Computer models and scenarios have been defined by the IPCC. I don't know if you know what that means, but it's the United Nations International Group on Climate. And all the climate scenarios that you've heard, and of course the COP that just was completed, where all the countries in the world get together and talk about climate. I talked about attribution science. And of course, this is often not given much credit, but it's very important. We have scientists with a lifetime of experience and expertise. Just alone at the CAC, we have 125 years of experience in our lead scientists. And it's really important to have that view from the past to the future, right to the present and into the future, in all of these areas, because it helps put it into context what we're seeing now evolving in climate. So the forecast inputs, the trends and their changes, the changes in frequency and amplitude of climate disruptions for rainfall and flood, sea level rise and storm surge, which can be related, heat waves, forest fires, and droughts. And boy, are we ever having it. The great warming that's occurred now so far, I know this doesn't sound like a lot because you probably can't distinguish the difference between 2.2 degrees Fahrenheit on a summer afternoon, or maybe you can a little bit, but when the whole globe warms up 2.2 degrees Fahrenheit, and that's just since the Industrial Revolution, that's a huge change to the system. There's a lot more energy in the system now than there used to be from the rise of global temperatures. And the increasing temperatures are not just the tip of the iceberg, because it's not just the amount of warming we're having, it's the rate of warming. And since the rate of warming has doubled since 1990, we've seen how extreme events have risen. In the last 2 years, for example, and the CAC is only 2 years old, we've had 41 climate-related events in the United States that cost over $1 billion each. That's a record. And in just the last 2 years, the damage from those events was $225 billion in the United States. That's getting to be serious money, even by our standards. Climate disruptions have basically exploded. And to reduce the risk, we need to dial back the rate of climate warming as fast as we can. And that's where greenhouse gas emissions come in, and this world focus on lowering those gas emissions as soon as possible. So as I said, the rate of warming has doubled since 1990. And at the rate that we're going to reach that 1.5 degrees centigrade threshold you've heard about by 2030, and the 2 degree threshold by 2050. So the more we wait, the worse the impacts are going to be. The worse the impacts, the more people are going to be impacted. And of course, usually it's the people who can't afford to be impacted that are impacted the most. So that's just one of the nature of these things. So now let's get into the forecast. Basically, we're going to see about a 3-degree increase in summer nights in August. We'll see a 3-degree warmer temperature. So if you think it's warm right now in our area, the average low temperature in the summertime in 2050 is going to be about 80 degrees. Summer days will be commensurately warm, and we'll see our 95-degree high temperatures, which we experience 10 times a year now, go to 60 times a year. In a minute, I'm going to show you a chart about how heat and humidity are related, and the 120 number is an extreme number, and I'll show you why in just a minute. And then in the wintertime, I'm sure we won't complain about this. Our average low temperatures will actually rise to about 55 in January, and our average high temperatures will rise to about 74 in January. So these you know, it's not just gloom and doom for the snowbirds. They'll love January more than they do now in 2050. So this is the heat and humidity index. And when I say we're on the edge, you can look at this chart and see why. Our average humidity is 65% or so in the summertime. And if our days get to 95 degrees, the heat and humidity index will be at 118. If you look down below, there's one more number, and I believe it's 129 or 8. The white circle's right over it. I can't really see it. But then the number below that, there isn't one. And that all those missing data in those red boxes are because people can't survive outside without air conditioning in temperatures above that. So we're rapidly reaching a point where the environment that we have in life, the way we know it today, is going to be impacted in a severe way, not just by the events of hurricanes and things like that we'll talk about in a minute, but just the general condition that we're living in will become more and more unbearable in the summertime. And parts of the world will see, will be in that no man's land where people really won't be able to survive unless there's air conditioning 100% of the time. And by the way, just to say that, imagine a major hurricane hitting Tampa in 2050, let's say, when it's 95 degrees and 65%, and being without air conditioning for a month in the summertime. That could happen. And if that does happen, it won't be good for human health, and there'll be plenty of casualties. So what we know about climate so far is that the oceans are warming, and a warming ocean is rocket fuel for storms. Deep warm water really is key to tropical storm and hurricane development. And that's why we're seeing storms that are spinning up at record rates. We call it explosive intensification, where a tropical storm on one day could be a category of 4 or 5 the next day. And as the Earth warms, it's not warming at the same rate everywhere. The Arctic is warming, for example, 2 to 3 times faster than the poles. And so what that means is that the temperature difference between the equator and, say, the North Pole is actually diminishing the difference between the two. And that means that the jet streams that move the energy around the Earth are moving to the north, and they're becoming weak in the tropics. And that allows for hurricanes like Hurricane Harry and Hurricane Dorian to slow down and actually stall over very heavily populated areas like they did, and create massive flooding like you see in this picture, which was Houston, Texas 3 years ago. The other thing is, people don't realize, but wind speeds are exponential in the damage that they cause. And what that means is that when the winds of a minor hurricane, a 75-mile-an-hour Category 1, for example, increase to 100 miles an hour, the damage doesn't go up 25%, it goes up 10 times. And when it increases from 75 to 125, it's 60 times more damage. And 185 mile an hour storm like Hurricane Dorian or Hurricane, I can't remember the name of it now, but the one that came up through Florida a couple of years ago, Irma, if it struck Florida as a Category 185, which is Category 5, and it did have that wind speed at one point, it would have been 1,300 times the damage of a Category 1 storm. So this is very important, and for a lot of reasons. And our leaders that set building codes have to understand that the buildings that are being built now and in the future need to withstand Category 4 and 5 hurricane impacts. And that means a huge change in the way we do things. But if we just say, okay, let's just wait until we get hit and then we'll react to that, we're going to spend an awful lot of money and may not be able to recover from some of these storms in some areas of the country. So people say, well, you know, how do you know that these storms are increasing? And so I did a little chart here. 1960 was when we started having satellite coverage. And since then, it would be hard for a hurricane to hit any land area without being detected first on the satellite. Perhaps in the olden days, in the 1850s, that could have happened in remote areas and we didn't even know the storm existed. But today, since 1960, we can measure how many storms there were with 100% accuracy pretty much. And so Category 4 storms from 1960 to 1980, there were 16 and 7 Category 5s. And if you look at 2000 to 2021, those numbers doubled. Isn't that interesting? Because the rate of climate warming doubled during that period as well. So the forecast for Category 3 to 5 storms is that, this is a little dated because we're in 2022, but in 2020, we had 7 Category 3 to 5 storms, and then in 2021, we had 4. The baseline now is 3. That's what we consider average now. And by 2050, we think that we'll see on average a doubling of that rate of Category 3 to 5 storms. That means Southwest Florida, just on that fact alone, really has increased risk to get one of these storms. And we've been very fortunate. We've skirted these storms, but you know, the probability of us keep skirting them is going down. Also, longer hurricane seasons are going to be normal too. Now it's May 15th to November 30th. By 2050, I think it's going to be April 1st through December 31st. So not only will we have more storms, but we'll have a longer threat period for being struck by them. Here's an example of Hurricane Irma, which hit this island called Dominica 3 or 4 years ago. And the image on the left is the day before the hurricane hit, and the image on the right is the day after. And you'll see a distinct change in color, and that's because there wasn't a tree left on that island. And actually, the inhabitants, all of them, had to be evacuated for several years until the island could recover. And now some people are moving back there. I'm not sure that's a good idea. So the average number of storms is going to increase from what we have 14 now to 15 and then to 18 by 2050. Also, this is very significant. Historically, the hurricane paths are in the blue, and you'll see how that one storm, Michael, that came up and hit Mexico Beach in Florida a few years ago, followed almost exactly that path. But now with the warming, we're seeing that the path is gradually shifting to the right. And that means the west coast of Florida becomes more of a prime target. So not only more storms and stronger storms, but their paths are moving further to the right. And this is information that planners can use right now to get ready. It's not okay for people now who are in a position to make decisions to sort of put their head in the disappearing sand. So sea level rise has been 9 inches since 1950. The rate is increasing as well. And of course, now we know enough that we can say we shouldn't be developing any new properties below 4 to 5 feet above sea level. You may have heard about the moon wobble. What is that? The moon actually has an orbit that takes it very close to the Earth on 18-year cycles, where it gets close to the Earth and then it gets far from the Earth. And of course, the moon is a big influence on tides, especially high tide. And in the mid-2030s, we're going to see the moon coming very close to the Earth again, and that's going to raise sea level on its own by 4 to 5 inches in our area. And that's significant since we've already lost 9 inches. And so that's part of the sea level rise forecast. At St. Petersburg, for instance, 9 inches since 1950, that rate of rise is increasing. You can see it right here from 1944 to just last year's data. You can see that that red line, which is the average rate of rise, is increasing. It's not just a linear increase, it's increasing its rate. And so what does that mean? This is a little study I did on what the annual flooding in Tampa Bay area will look like by 2030. All of those red areas are areas that will flood annually on average by 2030. Now, by 2050, as we move to South Tampa Bay, you can see some of these areas on our barrier islands, the Anna Maria Island and South Tampa Bay, all the way down to Sarasota area. Those red areas will have flooding on average of once a year by 2050. So of course, if the increasing flood danger is that much, we shouldn't be doing new developments in those areas now. And in fact, we should encourage people to move to safer areas now while we have that choice. Here's an annual flooding for Sarasota. I live in Sarasota, and you can see St. Armand's Circle. Many of you have been there, and unfortunately, the bridges don't show because they're not part of this. Obviously, some of them could flood, I'm sure. But these are the streets, and by 2050, we could see annual flooding in these areas, and you can see how the barrier islands are going to take the brunt of it. But even along the shoreline of the Sarasota Bay, we're going to see increased flooding. This is downtown Sarasota in 2050, and if you look, you'll see 789 and Golden Gate Point in these areas, and that's the bridge that goes from Lido Key to Sarasota. And annually, that's going to flood at least once, and parts of downtown Sarasota will flood at least once by 2050. So what should we be doing, say, in areas like this? And every town has these areas. This is not unique to Sarasota. It just happens to be a point of interest for me personally as I make my real estate decisions. But some of these roads can be raised, and the threat can be mitigated by doing that. Now, this won't solve our long-term problem forever, but it gives us more time to solve the long-term problem by taking action now rather than waiting for the disaster to strike and then reacting to it. All of us who live in the Tampa Bay area remember Tropical Storm Eta on 2020. This is a picture of downtown Sarasota, right about that area I showed you that would flood by 2050 annually. Eta was only a 70-mile-an-hour tropical storm, and we had epic flooding along the coastline from Sarasota all the way through Tampa Bay. It shocked people. There were hundreds of thousands of homes that were flooded and millions of dollars of damage from a relatively minor tropical storm. When the sea level rises, as I think it will, another 11 inches by 2050, this situation is going to be even more common. And imagine what it would be if a Category 1 or 2 storm hit, which is very, very likely. And part of the reason why it's so interesting from a meteorological and climate point of view is the continental shelf on the west coast of Florida is very, very shallow. Just look at a satellite picture and you can see the continental shelf that used to be Florida thousands of years ago, that's now underwater. But for every inch of sea level rise, means we lose 12 feet of beach on average with the slope that we have on the continental shelf. And that's why even 1 inch of sea level rise is important. So our processes need revision. Every public works project should have a climate resilience test now. The process needs rapid updates because the threats rate is going up much faster than the process is updated. So why should we spend public money knowing flooding's for certain and improvements aren't scored that are planned for certain climate events? So that's just one example of things that we can do about it. But to do this, we need to do it regionally, not one little town at a time, all towns doing different things. We need to coordinate our approach regionally. So basically, we have this triple threat from water. We have sea level rise, we have storm surges from increasing hurricane activity, where the storm surge is going to start from a sea level that's higher than it is now. And we know about the extreme precipitation where we're seeing these flash floods, not just so much in Florida, but in places like Houston and New York City and in Tennessee last year, et cetera. Florida is not really going to be going underwater permanently anytime soon. But what is certain is we're going to have more flooding more often and more severe. So the sea level rise forecast is that 2 inches by 2030. By 2040, we'll see an additional 5 inches on top of that. And then in the 2040s, by 2050, we'll see another 4 inches for a total of about 11 inches. This is the forecast we issued last November at the CAC Annual Climate Conference. Last week, NOAA issued its warning itself, and its forecast is for 12 inches. So you can see the agreement of scientists that now that we face a very serious sea level rise problem in the next 30 years. So this is not a problem for somebody else, folks. This is a problem in our lives for us. And that's why we need to adapt and mitigate now. Red tides and hurricanes are also related. We know that hurricanes, once they soak the Florida peninsula, the runoff goes into the Gulf of Mexico, which is warming up. And those flows are loaded with nitrogen and fertilizers that create red tide blooms. We saw what happened in Tampa Bay when we had a spill last year. Bloom was already in process, and when that spill happened, it became really serious in Tampa Bay. So as the climate warms and we get these heavier storms, we'll see more and more red tide blooms as well. So you know, most people don't realize this, but the Gulf really usually cools below 60 degrees in the winter historically. And what we've noticed now is that half of the time the temperatures don't go below 60. That means that the Corona brevis, which is really red tide, never really die out during the winter time. And then they start spring with more brevis in the water, and we have more and more red tides, and there's all these other impacts as well. So I want to just go now to the cost. The Center for Climate Integrity estimates the cost for climate protected infrastructure in in Southwest Florida, our basic CAC area, as about $4 billion in Sarasota, $6 billion in Tampa, $2 billion in St. Petersburg, and look at Naples, $6 billion just there. And in all of Florida, $75 billion. I think this is a low number, but this is by 2040. So in the next 20 years, we need to invest well $75 billion, at least to have some resiliency against what's coming. So our economy really is really, really important. And we've got to start thinking of climate warming as an opportunity from an economic point of view, not just as a threat. The adaptation and mitigation strategies are really the largest economic opportunity maybe we've ever had. But to realize those, governments are going to have to get in front and not just react to disasters. And that needs to happen now. Our planning, our zoning, our building codes, and a move from jurisdictional overview to more of a regional cooperation model so that we can get things done in an area, in a region, quicker, spending less money with more agreement on what needs to be done to cut the time between plan and action. Private enterprise, of course, is at the center of this. It will have to implement with the support of lots of funding from governments. And of course, we need to innovate, fund, and deliver products and upgrade what we call the climate economy, to realize the climate economy. The climate economy was probably our biggest growth opportunity that we have. Academe, which of course is so important in our system, really needs to focus its resources on the grand challenges that we have in the world. So instead of just training accountants to be accountants, accountants have to be trained to think about how they would use their skill to solve a grand challenge like climate warming. We need to turn out tomorrow's climate workers. And we also need to focus research on the things that we don't know, that we need to know in order to be effective in our mitigation and adaptation strategies. And of course, we need entrepreneurial science. That means not science that's driven by the ability to get a grant, but science that's driven by the holes in our understanding. So all of government and private enterprise and academe are going to have to work together, and they're going to have to shift the way they do business now, because the way they do business now is just too slow for the threat that we have. So I want to end by just saying it's so important that we grow our membership in the CAC. We have Category 1 through Category 5 memberships available. And I think by 2050, we're going to need a Category 6 designation as well. To get information about this, you can email me here, at this address, and you can also make donations to the address on the screen. And I want to end by saying, right now, until the end of March, every dollar that we receive in donations is going to be matched, not once, not twice, but 7 times. That's an extraordinary leverage that we have now, because we have donors now that really see that the CAC is sort of different and unique. And if this one is successful, we can have them in other areas. So they're really investing in making this one work. So with that, let's take some questions.
Thank you, Bob. You finished right in time. Actually, I was itching to just intervene to say that you have 1 or 2 minutes left. So we have plenty of time to ask questions. So we open the floor or the stage or whatever you want to call it virtually for questions to Bob. Please raise your hand and say who you are and ask your question briefly. Okay, Kabreb, Gabriel Michael, one of our faculty members. Kabreb.
Yeah, so Bob, I think this is very, very interesting presentation. So thank you for that. My question is, in your forecasts, did you consider some mitigation measures so that you forecasted different scenarios? And second question is, now the cost for resilient infrastructure is 75 billion. Now, what would be the cost for mitigation?
So basically, the climate infrastructure is mitigation, raising roads and protecting shorelines and building sustainable beaches and things like that are all part of that number. Those aren't my number, but that was an independent group of people that were considering at a minimum what we need. And of course, this is for business as usual. If the more we do now early, the more money we're going to save in the long run. We can see what the cost of climate disruptions are. Like I say, the warming that we're having is not so important for the warming itself, although it's going to become more and more important. But it's important for the climate disruptions it's creating in our daily weather. And that is impacting differentially the rich and the poor differently. The poor people who get to buy affordable housing that's in a floodplain are the ones who are wiped out when something happens first. And if we really care about, being more socially smart, I would put it, then we really have to start this mitigation now. And it needs to start with not allowing housing to be built in these areas and things like that. We know what's coming. We just don't want to deal with it, but we need to deal with it.
Okay, Bob, if I may ask, so much of what you said is, from our college's point of view, it's kind of preaching to the converted, if I may. So you have put some challenges for us, entrepreneurial science, and I mean, we are more of what we call a do tank. We want solutions. That's our educational approach. But the question I have is more in terms of a science communication point of view. In this age of distrust of science or expertise, and it is getting even worse, people just opinionate about everything as if that is the fact. But unfortunately, that has become the norm. Now, one thing we may be able to do, I mean, I don't know that we have a solution, is that we have to have buy-in from the public to have an impact, whether it is to have some sort of some way for them to say that, hey, things are going to be worse, that you have to pay some cost in terms of what. So my question is, when people say here that, oh, by 2050, we are going to have 1.5 degrees Celsius or 2 degree Fahrenheit, people might not think that is really serious. I mean, they might think that, hey, some in extreme weather events, it can go fluctuate from 10 to 20, 30 degrees. So what's the big deal, right? So you put in that, through in that term, energy intensity or whatever. So we need to have a better communication way, method of conveying what is out there. It's going to happen in a different manner. Like the Richter scale, for example, is a logarithmic scale. 8 to 9 can be catastrophic, or even 8 is even so high. I was in Japan in 2011 when that big earthquake happened, the tsunami and things like that. I mean, that was a big one, 8.3, I think. So do you have as a scientist, I mean, some suggestions as in a different way of communicating the consequences that we can have?
I think it's an excellent question. And so I'll tell you, most of my career was spent top down as a scientist running a major institutions, helping manage major institutions, being a scientist in a global environment, doing global climate research, weather forecasting, and things like that. The reason we created the CAC is because after 40 years of that, we have made so little headway because it's not a fair argument in the public domain. One person's, I mean, in this age of social media where everything is a conspiracy, it's hard really to rise above that and to have a real conversation. That's exactly why we formed the CAC, as a public forum where we could educate, make these complex things easy to understand, and give people quantitative numbers of what they're going to be facing, because they do understand that. And it's hard to argue once you put it out that way, because what is the counterpoint to that?
Right.
That we don't know what we're talking about? And everyone who has seen weather and climate forecasts over a period of 30 years knows that we used to have the little weatherman with the sunshine on the tube, and we found it entertaining. But now, I mean, if I say there's a 70% chance of heavy rain in Sarasota, you better damn well bring your umbrella. So, I mean, we have gone to a different state, and the information now has skill in it, and it has real actionable information in it. And now all we have to do is decide to use it. So building this from the ground up is the answer, in our opinion. And the CAC that we have in Sarasota is our first prototype, but we already have interest in having them in other places around the country. And on our website, we have people logging in from all around the world watching what's going on in Sarasota. So if we're successful here, and we can make it successful here, then we will bring science to the local community in the way people can understand it and act upon it.
Excellent. I'm sure there are several other people out there waiting to ask questions. I have many questions I can ask. Of course, we can talk about it later. Marin Levine, if you want to ask a question.
Hi, Bob. I think that's another excellent presentation, very impressive. And the data and the information that you presented is really compelling. The one thing that I think is extremely powerful, in addition to everything else, is that map that shows the sea level rise around the barrier islands in Sarasota. There is nothing as convincing that this is a disaster on our shores about to happen as that map. And so I think this is something that you considered, but I think people leave your talks knowing that we need to do something. We need to have coordinated responses. We need to put resources behind these threats so that we minimize the catastrophes. What seems to be missing is the organization to bring these very important groups together. And by groups, I don't mean little groups. I mean like governments, private sector, all the groups that you know about. And I'm just wondering two things. One is whether you know of any organizational entity that has the capability of bringing these particular sectors together, or two, whether the CAC could expand its mission to be that catalyst. Because I think for the end of the conference you had in November, which was exquisite, and this discussion, which is really powerful, the end result is that we don't know the next step for getting all the interested organizations together to really come up with a strategy, a plan, and the resources to make something happen.
Well, that is exactly perfect. And if on our website it says the CAC is a forum to bring those three parties together. And in fact, in our conference that we had at USF in Sarasota in November, we allowed people, the last two conferences, to buy tickets to see who selected in. And it was remarkable. We had 300 people almost at that conference. There were 100 from government, 100 from industry, and 100 from academe. And they almost self-selected in equal proportions, which shows to us that we're starting to get that coalition, but we need to have a bigger presence, more staffing, more staff scientists that can go out into the community, to the individual sectors, and actually recruit them in and give them the information that they need. So for example, a Category 5 member of the CAC gets an individualized briefing to whatever group they want once a year by our scientists. That's a way to reach out and go out into the community and then bring them in. When I was at NCAR, we had this thing called the Corporate Affiliates Program. We had an annual meeting every year, and the CEOs would come to NCAR, and we would give them a program about whatever it is they were interested in and bring the world experts to them. And that's what we're doing to our communities, because the experts really, I mean, to the extent I'm an expert, I do live in Sarasota, but not every community is going to have access to this kind of talent, not my talent, but the talent of people like Bob Carell and Stu Waterman and other scientists and people in industry that are doing things that have already done successful things on mitigation that we could learn from right here in Tampa Bay area. So a lot of the answers are already known, but we don't know them in our community, and we need to make that known. And we hope that our CAC conferences become the forum for that. How that evolves over time will really depend on how much support we get, because of course our will is strong, but it still costs money to do these things. And you know, everyone knows that you can't do it just basically because you believe in it, but that's where you have to start, and that's where we've started. And I think we've come a long way in 2 years for a brand new not-for-profit organization that started, you know, probably in an area where a lot of people don't want to believe about climate warming.
Right. So I'm sure that there'll be other people waiting to ask questions. So please do raise your hand, or even you can also write in the chat section. You can write your question. Now, Bob, I'm also itching to ask this question about the so-called black swan events for modelers and forecasters, or you use Rumsfeld's phrase, you know, the known unknowns or unknown unknowns.
Right.
So, so how do you incorporate such things? For example, unexpected, totally unexpected. You know, in economics, they know these things. They know how, you know, now the Ukraine war, or you know, Russia's aggression in Ukraine,
right,
or rattling with the nuclear, you know, Armageddon. You know, we have dealing with the crazy people around the world. You know, so I mean, so you know, the gist of my question. So how do you incorporate that?
Well, so really, I think what we have is we have two really nonlinear things going on. One is the atmosphere itself has a certain limit of predictability. It's, you know, we called it the butterfly effect, chaos theory, where, you know, the butterfly flies in Indonesia and we have a hurricane in Florida. Okay, that's the extreme sort of way to put this, but the atmosphere is mostly predictable, and it's more predictable than we thought it was in 1980, because we've learned so much more about how to predict something that we didn't know. So there are many things we still don't know we don't know, but more and more we know what we don't know. And we know so much more if you get the cascade of things. So we're getting better at it. And while an extreme event certainly can happen and will happen that comes in from left field that we have no idea of, the risk of that is minuscule compared to the risk of what we do know is going to happen that we're not getting ready for. So if we can cover what we know now, 30 years from now, with the rate that we're learning, that knowledge is really doubling every 25 years now. Imagine all the knowledge of the world will double in the next 25 years. All the knowledge from the beginning of civilization to now will double in the next 25 years. And I believe that in that knowledge base, we will learn how to control the climate in a better way, either by sequestering carbon or other things that we don't even know how to do now. We will know how to do. But the key thing is to get there from here and sustain our way of life until we get there. So that's my optimistic view.
Oh, yeah, absolutely. I agree with you, because the flip side of my question is precisely that. A lot of people out there think that, oh, we don't know what the future is going to be. Why should we do anything now for something that might or might not happen in the future? But you reassured me. Climate science is much more stable in terms of what we can predict.
Well, we do know the sun is going to rise tomorrow and it's going to set tonight. Yeah. And so when you have that kind of surety, you can make decisions about what you're going to do in the next 24 hours. We're not quite that sure yet, but we're getting closer. And so we don't have to wait for more information. The longer we wait, the higher the risk will be.
I think we have a hand raised there, which is Deb. Please, ask a question.
Yes, thank you very much. Bob, I thought that was an outstanding presentation. I find the work that you're doing at CAC really critical in terms of dealing from the ground up, which is really, as you say, where all the solutions are going to be. Since I work in the world of sea level rise, I had a question for you on that. The NOAA report came out recently, of course, and I'm aware of your prediction from last November. Are you aware of the recent NASA study looking at Greenland and the extraordinary melt coming off of Greenland that was not accounted for previously, because it just closed out toward the end of the year?
Yes, and I have read some of the papers on that, the latest peer-reviewed papers. And interestingly enough, Deb, we just did a 3-part series on the Arctic that's on our CAC website that explains various things that could impact sea level rise that we haven't really factored in a big way, and we're waiting to see what happens. These are the things that we sort of know that we don't know, that we're watching. But when we say 11 or 12 inches, depending on whether you want the CAC forecast or the NOAA forecast for sea level rise, I mean, it's within the margin of error. But what we're all, and this is what Govardhan was talking about, we could learn tomorrow that something more severe is happening that we can't see from underneath the, say, Greenland ice cap or the Thalways Glacier in Antarctica that could change the sea level forecast. But what I'm trying to say is I doubt if it's going to get better. And if we can't deal with what we know is going to happen, how the heck are we going to deal with what we don't know?
Yeah, I hear you on that. The suspicion of many of us in the world of sea level rise is that these numbers that you cited are on the very conservative side, given the level of melt that's coming off of Greenland that was literally unknown until the NASA study, and similar studies are underway in the Waddell Sea and down in Greenland, looking at that, because the variables, of course, for predicting sea level rise are immensely complex. But nonetheless, we're really concerned that these numbers are pretty conservative. So we're going to be watching that space, and anything I find that I think you folks may need to know about, I will see that you get the links.
I would love that. And I just one quick comment is the reason why we have the annual climate weather forecast is just for these reasons, because as we learn more, we revise the forecast and make it the best we can for every year. So we're starting with what we have, and every year we'll refine it. And I'm sure it'll get better and better with time.
Thanks, Deb. I see Kabrab is an old hand, or if you want to ask anything new. Oh, you're okay. It's not old. Okay. Go ahead.
Hello, Dean. It's Kabrab.
Kelly. Yeah.
I'll go after Kabrab.
Your hand was up, right, Kelly? Okay. Sorry, Kabrab, if you can wait a minute or so. Yep. Okay.
So who was, me or Kelly?
Kelly, yeah, first before you ask. Yeah. Kelly. Yeah.
Thank you, Dean. So, Bob, earlier, shifting over to the academic side of your career, we had spoken about the work you did at the University of Colorado in founding the entrepreneurship program. And as a director for student development and alumni relations at Battelle College, one of my roles is helping our students prepare the necessary skill sets and helping our alum with finding sustainability careers. And you mentioned to me entrepreneurship is essential for our fight against climate change. Would you be able to expand a little bit on that?
Yes, you know, it's amazing. We have we sort of have this aircraft carrier that's moving around, and to make it turn, it's very difficult because it's such a massive enterprise. The United States is a massive enterprise, a $22 trillion a year enterprise. It's even hard to think about that much money. I think it takes 6 trillion, and we could buy every single family greater than one person a brand new Tesla with 6 trillion. So that'll tell you what 22 trillion is. It's a lot. And to change course is very, very difficult. But where change is rapid and loved and understood is at the entrepreneurial level. Most of the innovation is going to come from that level. And that's why I am so high on students focusing on entrepreneurial endeavors that are where climate change is the focus. We can bring students from all different disciplines, whether it's psychology or engineering or science or mathematics or history, whatever it is, and we can bring them in to what I call a co-laboratory on climate warming. And we put out there, this is the grand challenge. Let's develop some strategies for how we'll solve it using your skills that you're learning at the university. So what we need is an overview that stimulates the entrepreneurial students. That they already are excited about what they're doing. And if we can teach them how to apply their skill to solving a global problem, it's going to get solved a lot quicker. And in it, they're going to start companies, they're going to make money, they're going to have a nice life, they're going to employ people. That is the climate economy. But we're missing this connection because the United States does it better than any other country, and that's why we're the best country in the world from an economic point of view, is because we can push the sectors together when we have a challenge, and we create an overlap, and that's where innovation really exists. It doesn't exist alone in any sector. It exists most potently when we push those 3 sectors together. I call that area where they intersect the blur, and that blur is where innovation happens because there are no walls there. No longer are we in silos, but we're all working together to solve a common problem. That's what we need here. We can do that. We know how to do that. We just have to decide to do it and make it a priority. So I hope you guys will be the leader, because if you show people how to do it, everybody else will follow you. You know, the CAC at the beginning, nobody wanted to talk to us. Now everybody does. Success is really, it stimulates a lot of things.
We hear you, Bob. We hear you. We want more entrepreneurs and solutions. Thanks, Kelly. Bram, did you You want to ask this question because it could be the last question. Yep, for Bob.
I don't want to keep everybody, we are already.
Oh, don't worry. Yep.
Okay, my question, Bob, is now we're looking at the greenhouse gas emissions inventory for Florida.
Yes.
We know that energy accounts for up to 80% of the greenhouse gas emissions. But at the same time, we see that we're looking at more renewable energy, electric vehicles coming into the market. Are you optimistic that if we go along this line with more renewable energy and electric vehicles, we can do better in terms of your projections?
Well, I think the electrification of the world is a very important aspect of how we can deal with climate warming and start to lower emissions. But that is really not just an electric vehicle as only part of the system. We have to look at the entire system. What is powering the grid that supplies the electricity to the cars and the trucks and the transportation vehicles and everything else that's going to be electric powered? I'm going to say something now. I know a lot of people are going to think I'm crazy. The biggest mistake we ever made in this country was getting off of nuclear power.
I hear you. Yep.
And it's the only really, in my view, it's the best transitional technology we have. We've learned so much about it and how to do it well. No one has ever died in the United States from nuclear power, from electricity generating, not one person. But people have died going down the elevator shafts, but we haven't banned elevators in buildings. I mean, it's just the most ridiculous thing I've ever seen, and we have to get over it because we can build nuclear power plants for 1/10 of what they used to cost in 1/10 of the time. And if we cleared the way to do it, we could supply the entire electric vehicle power grid with the nuclear energy. The problem is that the clean energy, and I'm all for it, we don't have the storage capacity for it. And when something big happens, like a big bump in use, we can't handle big bumps. And energy, we know that we use it has peak times at night. It's not very much, and during the day, it's really heavy. And if we have a cold season come in, it can triple the energy use in a matter of a couple of hours. And the clean energy just isn't resilient to that yet. It will be, but it's not now. So let's get on with nuclear energy. It's the best solution that we have. And we can't do things that have zero risk. Nothing that we do has zero risk.
I agree with you, Bob.
Thank you. Yeah, that's good.
As a power systems engineer, because I studied nuclear power, I agree with you completely. This is something that we missed the boat. But the French are building more nuclear power plants, and the Chinese are doing the same. But there are some political issues related to proliferation, things like that. So
I'm just going to ask one question. If the Germans didn't turn off all their power plants, which supply 30% of their energy, would Russia be invading the Ukraine today?
Nope. I mean, that would be a very important part of the calculation.
I don't know the answer, but I think it would have been more difficult.
More difficult, yeah. If the Germans could just close the second one too, yep. Not the the first one, not the goes to Ukraine.
All of a sudden,
anyway, I think we have ran out of time. Sorry that we have to stop. Have another conversation another time, and we could talk about nuclear power. Maybe that could be an I'm willing to talk and stick my neck out there, and then advocate for nuclear power. Because in fact, even Greenpeace at one stage said that even 2050, the world is going to go down. And if nuclear power is something that's going to save us, why not? So we should think about that. But anyway, I want to thank you so much for the stimulating conversation this afternoon, Bob. Thank you so much. And we'll be inviting you back to give another presentation or even teach even a course or whatever that we can work with you or co-teach or be part of one of our academic programs. I would love to have that conversation. So thanks, Bob. Thanks everyone for your
Thank you,
input.
Bob.
Yep. Bob, you're frozen? Hello. Well, I think Bob is left. I don't know.
Thank you, Dean. Next
You
week.
maybe timed out, or maybe that's possible. Anyway, thanks everyone. Yep. Thank you. Okay, Kelly. Yep, you have the final word.
Yes, thank you. Next week we have a speaker, Angela Prasad Reddy. She'll be speaking about plant-based healthcare and how you can attain that goal. And also today's presentation will be available on our website this evening. Thank you, everyone.
Thanks. Bye. Good night.